Hello, I'm Berenice Humphreys, Senior Projects Manager for Clifton Conservation. I'm based in our Bath office, but also look after our regional office in Norfolk. On behalf of Nick Cox Architects and the client, Wells Cathedral, we carried out a pilot phase of works to part of the west front of the cathedral in summer 2021. These works were collaborative in nature, but not experimental, as we had the benefit of surviving historic repairs to learn from. Some 40 years have elapsed since the last major phase of works, and the intent of the pilot study was to refine and update techniques in order to carry out works across the whole of the West Front in a future phase of works. The West Front of Wells Cathedral is a riot of early English sculpture with some 300 pieces representing angels, apostles, religious figures and the so-called resurrection tier, figures rising from the dead. The stone is Dundry and Dolting, both buff-coloured limestones, with grey detailing originally provided by Blue Lias limestone. It's important to remember that the facade would have been painted, and tantalising evidence of this remains. As with any cathedral, the stonework at Wells has been subject to repair. Major schemes were carried out in the 1870s, 1903, the 1920s, and the most famous works, those from 1974 to 87. The last major phase of works was undertaken by Professor Baker and others, and the reports from those days read like a Hollywood A-list of well-known conservators. The works at Wells under Professor Baker helped to develop the lime method and inform many of the treatments that we still use today. The aim of the pilot study was to design and refine a methodology to be used across the rest of the West Front in a future planned phase of works. The focus, and the subject of many meetings during the pilot study, was to agree clear and usable methods of recording, to understand the current condition of the stonework and its history of repairs, and to develop repair strategies. The upper section at the west front, between the two west towers, was chosen, concentrating on the sculpture above the west window. This is broadly split into the following tiers: Christ in Majesty, the 12 Apostles, the 9 Orders of Angels, and the Resurrection tier. The basis for the specification was a mute survey carried out by Nick Cox Architects and informed by a preliminary study of the lower areas by David Odgers. High-resolution imagery was carried out by James Brennan Associates in 2016, and these photographs form the baseline for the specification. As we got closer to the building and a better physical assessment could be made, this specification was going to change. It was therefore important that the team developed a position of trust with the architect and client, as the entire project would require remeasuring. The works involve the following aspects: cleaning and removal of pigeon guano, nests and biological growth was an important first step to understanding the condition of the stonework. Recording of the current condition allowed us to assess the stability of both the historic repairs and the condition of the original stonework and how it was failing. Understanding the condition also helped us to make new proposals for repairs and present these for agreement with the architect and client team. A few key areas of stone replacement were identified, such as string courses or where larger pieces may be subject to failure and delamination. We also took the opportunity to refix some stone finials right at the top of the tower, after a hairy, wide-eyed moment on a windy day, watching them swaying from side to side. The majority of the repairs required were mortar repairs and shelter coats designed to consolidate and unify the surface. The three areas of work I'm going to focus on today are the recording, the mortar repairs and the shelter coats. Wells Cathedral is a popular roosting and nesting point for birds. Works to clean one of the apostles were halted whilst we waited for 2 jackdaw chicks to fly the nest, and the hundreds of pigeons were unperturbed by our presence, stealing our cable ties to make their haphazard nests. Wooden tools were used to remove the bulk of the guano, and a biocide, in this case algo bioinhibitor, was applied and left to dwell for 3 days before further cleaning took place. In some areas, a second coat of biocide was applied, where we could see obvious greening remaining. Water and bristle brushes were then used to remove as much detritus as possible, without damaging the fragile surface and losing additional material. Our aim in cleaning was to allow us to make judgments on repairs, and not primarily for the visual bling. We were also conscious that mortar repairs and shelter coats struggle with adhesion where dirt or biological growth remain. Our shelter coats did indeed react, with some white flecks appearing later on in the process. Discussions with various conservators within and outside the company suggested that these flecks might be a reaction to the alkalinity of the lime shelter coat, and perhaps represented the death throes of the growth beneath. Once cleaned, we were able to review the condition of the stonework, and importantly the 1970s mortars, many of which had survived remarkably well, with their form and even surface finish still apparent. Site meetings were held with the client team and all of the conservators to develop and agree the level of recording. It's important to note that we were not there to assess the reasons for decay, but to record the situation and to develop a methodology for further treatment. The recording methodology needed to be straightforward and practical to use on site. Whatever we did needed to be easy to digitise, but also easy to be read, uncluttered, and be able to show areas of concern both as a close-up and to provide a wider review across the building. The records also needed to be concise, limited in scope to that which aided our repair strategies. We were able to get hold of the high-resolution image produced by James Brennan Associate of the whole building and divided this into each sculptural piece and its surrounding architecture. This image, printed onto A3, was supplemented by a notebook, the aim being to mark up the photos with colour blocks, but also to clarify some of the detail with observations and notes. This would leave the photos uncluttered, but also allow for exploration of the issues in note form. Each conservator was issued with a multicoloured pen, and a simple colour scheme for marking up was agreed. We also agreed definitions and examples of the condition. For example, where mortar repairs survived, but were delaminated and failing, they were marked up for replacement. Where mortars were well adhered, but blistering was happening adjacent to them, these were marked for repair by filleting and capping. The end result were 3 documents and the notebooks: a condition drawing, a proposal drawing of repairs, and a treatment record. The individual treatment images will be combined in the report to give an overall image of repairs. This may help with future study of the mechanism of failure. The decay processes we noticed were delamination and loss of structure of historic mortars, blistering of stone adjacent to historic mortars, delamination and fracturing of the stone itself, and it took a keen eye in places to distinguish between stone and mortar. Losses due to inappropriate repair techniques such as cement or ferrous metals, and weathering of stone in vulnerable areas. On this apostle, the historic mortar has failed and will need to be replaced, having lost its structure and adhesion to the stone beneath. Typical of blistering issues were found to the angels at the junction between stone and mortar repair. We suspect that this is continued failure of the stone itself, which is peeling back from the substrate beneath. When it came to applying mortar to these areas, we agreed to carry the fillet over the edge of the blister to hold it in place and prevent some of the worst effects of weathering. Fracturing, more typical of frost damage, was also noticed, especially to the base of the angel figures, many of which had been repaired previously. The drapery to the apostles also showed vertical fractures, and we assumed that the numerous copper pins in place were to restrain these falls. It will be interesting to note the extent of protrusion of these pins and whether the protrusion acted as a datum for weathering or if they had been left deliberately proud. These areas were grouted and shelter coated and the pins just left in place. Cement is well researched for its villainous properties, and here is no exception. Spalling occurs adjacent to the hard cement repairs, and in some cases this is associated with ferrous fixings. The ferrous fixings were mostly left in place as they tended to be set in lead, doing limited harm, but where the cement was loose, this was removed and replaced with lime. We really struggled with the lack of access to the records of previous works. Nowhere was this more apparent than in the design of and application of the repair mortars. We used the notes gleaned from David Rogers' reports and from Nick Durnan's own personal notebooks, but it is notable that many of the materials available then are not available now. Before the project began, we sought out a source of aged lime putty, but were acutely aware that whatever we sourced needed to be readily available in quantities for future works. The same goes with some of the sands. The idea of using hot mix mortar was floated. However, this has no history in use as a repair mortar and could only be regarded as experimental on this project. We took the step of employing Nick Durnan on the project as a consultant, and to be able to get the benefit of not just his repeat experience of using lime over the years, but to tap into his memory of the actual methodology was vitally important on this project. We used 3 slightly different mortars on the project. One to give a brown colouring, one to give a more yellow colouring, and one to give a greyer colouring. These colour changes were made by adding small amounts of different dusts and aggregates to a base mortar of lime, Morton Cullimore sand and Dolting stone dust. Nick had suggested replacing HTI powder or Metastar with brick dust, due to his concerns over the years with the former becoming brittle. He also introduced us to limestone sands, on the basis that these appear to aid the porosity and adhesion of mortars. To prepare the stone to receive the mortars, we cut back to soundstone using fine chisels, checking for any delaminations. We scrape back and undercut where required, grouting to support delaminations with a fine slurry. We also use ceramic dowels to support larger mortars where 2 or maybe 3 layers of mortar were required. The mortars were mixed by hand after pre-mixing the sand and putty, just in small batches to colour match. As you can see, a considerable number of small mortars were required across the sculptures. These would be later shelter coated to tone in. Where possible, we followed the form and style of the sculptures. They were covered with heavy blankets, which we wetted and left on for at least 2 weeks during the project to help the mortars go off. Then they were scraped back when they were green hard and brushed. Repair mortars serve several purposes. They prevent water ingress from causing further weathering and fracturing of the stone beneath. They help to protect the fragile stone surface. They help to support adjacent material, and they restore the features and give a shape to the figure. Where the loss of material led to a loss of sculptural form, as far as possible we attempted to enhance the form to aid reading of the figure. For some of the sculptures this proved challenging, as quite frankly what we were faced with was an amorphous blob. But through endless discussions and meetings we agreed a method, and we hope we have given some life back into the figures. The surface of the mortar was tamped with a stiff brush once hard, or on occasion a small section of dolting stone was used to give a closed texture to the surface. Dolting aggregate was also added to the surface finish by pouncing, as Nick Durnan had remembered doing previously in the historic mortars, and in fact the evidence of this we actually could still see today. Designing easy-to-use shelter coats proved a real headache. Our remit was to use a variety of colours in order to patinate different areas, but like everything else on the project, they would need to be easily replicated going forward, so couldn't be made in small batches. After struggling with pigments, casein and different stone dusts, we finally achieved two main recipes for use based on the ingredients in our repair mortar mixes. We agreed with the client team that upper levels, such as the apostles, needed to have a greyer tone, but the lower levels, such as the angels, needed to be warmer, partly due to the effect the surrounding architecture had on them, but also the impact of the remaining polychromy. When you look at the treated areas, and in fact the entirety of the west front, this grading of colour is particularly apparent. We hope the work we have done can be seen as a success. The project began in April after a short delay to pay respects to the Duke of Edinburgh, and was completed in mid-August to a very tight deadline. Thanks, Sir Anthony Gormley. We endured high winds and rain and blistering sunshine and climbed many steps to complete the works. Whilst the works were challenging and headache-inducing, the entire team took great pleasure in working on this finest of English cathedrals, and we look forward to doing so again. Thank you for listening.